Okay, let's go to the next story. Close your eyes if you like, or keep them softly open. Let them fall into the gentle half-light, where room and sky breathe together. Breathe once, slowly, as if inhaling a secret the universe has been whispering for billions of years. Breathe out. Release the day, like a small stone dropped into a wide, patient pond. Tonight we will walk, softly and carefully, along the edges of wonder. Imagine first a single point of light, far beyond the reach of your fingertips. It hangs in the vast blue-black, a patient ember in the dark. That light is an ancient letter, written in photons and carried for eons across loneliness and time. Each photon is a tiny messenger telling a story of clouds collapsing, of pressure building, of eventual fire. It tells us how a star was born. We begin in a nursery, not of cradles and lullabies, but of dust and quiet gravity. In these vast stellar nurseries, clouds of hydrogen breathe and sigh. They swirl and settle, a slow, graceful choreography. Regions within them grow heavier, tiny seeds of density that call to each other. Gravity, subtle and relentless, draws them closer until warmth blooms in the heart of a contracting cloud. At first, there is only the hush of atoms colliding, but then the hush becomes a murmur, and the murmur a steady hum, the birth heartbeat of a star. Picture that newborn star like a candle cupped against a blizzard, fragile yet defiant. It begins its long work of turning matter into light, forging heavier elements in its crucible. Over millions or billions of years, it is both creator and instrument. Carbon, nitrogen, oxygen. These are not gifts dropped from nowhere. They are the labor of stars, the slow alchemy that stitched the periodic table into patterns that would one day be read by biology. Drift now to the patient geometry of planets. The protoplanetary disk that surrounds a young star is a slow-turning carousel. Dust grains stick like shy dancers, finding partners. Pebbles accumulate to rocks, rocks to boulders, and boulders, by a kind of stubborn fortune, become worlds. Each planet falls into its lane, some near and scorched, others distant, wrapped in the deep sleep of frozen gases. Some catch thick atmospheres and wear them like robes. Others are bare, their scarred surfaces reading like old maps. Listen. The language of geology speaks in storms and tides, in continents wandering on oceans of rock, in the patient corrosion of winds. On some worlds, water pools and waits rivers tracing the skin of the planet, oceans breathing with the slow rhythm of tides. Where chemistry and liquid meet, curiosity becomes possible. Where energy is steady and ingredients meet for long enough, chemistry can begin to take the first timid steps toward biology. Life, when it appears, is not an announcement so much as a very quiet persistence. It is the universe learning to know itself through rearranged atoms and the improbable poetry of replication. Let your mind stroll now beyond the pale neighborhood of a single star to the wider assemblies, binary stars that spin around each other in an intimate conversation. Systems where planets chase one another in complex arcs, moons that steal the stage and then return it. Imagine a night sky from the surface of a world that circles two suns. Dawn here and dusk there, shadows overlaying and unraveling, as if the universe were practicing a gentle illusion. Or imagine a planet where the seasons stretch for centuries, and an entire civilization learns patience from a slow, wandering orbit. We can come closer, closer than even the crescent of a moon, and meet comets. Comets are wayfarers, icy, ancient, carrying the scent of the outer reaches. When they approach a star, heat teases their frozen past into jets of dust and gas, creating a tail that points away, like a memory streaming behind a moving soul. Some comets have visited the young Earth, delivering water and organic molecules, small serendipitous couriers, possibly responsible for nudging chemistry toward life. They are reminders of how the universe keeps its treasures in remote vaults until the right moment. Now, allow the scene to widen. The galaxy is not a static painting, but a slow-turning ocean of stars. Our Milky Way is a disk of countless lights, an elegant swirl observed edge-on as a delicate line of soft brightness, or seen from within as a band of spilled sugar across the night. The galaxy's spirals are arms roots of ongoing formation, places where gas is funneled, compressed, and nudged into new generations of stars. At the center sits a quiet storm, a supermassive black hole, not a hungry villain in a storybook sense, but a sculptor whose gravity molds the dance of millions of suns. Black holes are not only endings, they are thresholds. Their gravity warps both space and time, bowing light as if the fabric of reality were a soft sheet. When a black hole feeds, it can make light brighter than entire galaxies, an irony that reminds us how extremes are sometimes necessary to create beauty. Around many black holes, matter swirls in a furious incandescent maelstrom, jets of particles leaping outward like fountains that pierce the dark. The mathematics that describe such objects are both austere and wondrous, a vocabulary where infinity and smallness meet. Think for a moment about the scales we talk about. Atoms to planets, planets to galaxies, galaxies to clusters, and then to the cosmic web. Between galaxy clusters, filaments of gas and dark matter trace a pattern like frost on a window. Dark matter, an invisible presence, holds the web taut, a scaffolding without which galaxies would not gather. Though we cannot see it with our eyes, we sense its gravity by watching things move as if pulled by invisible hands. There is humility in that. Much of what shapes the universe is one step removed from our senses, and yet is no less real. Time itself carries a story. The cosmic microwave background is a faint afterglow of the universe's earliest visible chapter, a whisper from when the universe was just a few 100,000 years old. It is cool now, a mere 2.7 degrees above absolute zero. But it is a map, a photograph of the infant cosmos, with tiny fluctuations that seeded everything that followed. To hold that image in your mind is to understand that even the largest things started as the smallest differences, tiniest ripples that eventually grew into vast structures. Picture the cosmic timeline like an old patient book. The first pages are quick and feverish. Inflation, a sudden stretching that smoothed space like kneading dough. Then atoms formed, light untangled from matter, and a dark age fell long and silent until the first stars lit tiny lamps that pushed back the gloom. Galaxies assembled, merged, and spun off new generations of stars. Planets formed from the debris left in the aftermath of these cosmic negotiations. In this unfolding, humanity appears very late, an afterthought in the second-to-last paragraph, and yet, in the human mind, a universe of meaning ignites. Let us visit one small chapter in which curiosity itself evolves. Consciousness. Somewhere in the long history of Earth, early cells invented a trick replication with variation, and then, over eons, nervous systems learned to sense. Brains are storytellers. They knit signals into patterns and name them. Consciousness is an emergent candle, lit by complexity, sustained by exchange, and flickering with memory. It is in this candlelight that we ask why and how, and in asking, we create narratives that fold the cosmos back onto itself. Imagine now an observer standing at the edge of a cliff beneath a trembling aurora, or a night watchman on a ship gazing at the stars smeared with meteor trails. The same processes that cook the insides of stars also create the copper in your phone camera, the oxygen in your lungs, the metal in a bridge, the calcium in a tooth. These are all descendants of ancient stellar furnaces. There is a soft, almost ineffable intimacy in that. The universe gave us, over long patience, the very elements that make selfhood possible. We can also sense the fragility of home. A planet's atmosphere is a delicate blanket. It can warm gently under a benevolent star and sustain richness, or it can be stripped away by flares and winds, leaving raw stone. Small differences in chemistry, rotation, or magnetic shields can mean the difference between a world teeming with potential and one that remains mute and barren. The history of planets is a study in chance and contingency. Local weather, global catastrophes, rare impacts, the ephemeral vicissitudes that shape long-term trajectories. Turn your attention now to communication across distances. Light is a faithful courier, but it travels at an upper limit. Signals sent across interstellar space take years, centuries, or millennia to arrive. Even at light speed, messages are delayed by the tyranny of scale. If someone on a planet 500 light-years away shouts into the dark, their voice is a letter that will arrive here only 5 centuries from now. That slowness teaches humility and patience to any mind that imagines sending greetings. Consider how we listen. Our instruments extend senses. Radio telescopes tune to the faint hum of hydrogen between galaxies. Spectrometers unweave starlight into colors and reveal composition like detectives reading fingerprints. When we find a spectrum with telltale signatures, water, methane, oxygen, we do a kind of forensic archaeology across time and space. We cannot visit many of these places. Instead, we learn to translate the light they send, to read whispers of chemistry and motion, and to infer landscapes from small, indirect clues. There is also the poetry of scale in motion. Galaxies collide not as catastrophic bangs, but as slow, majestic ballets that stretch across millions of years. When 2 galaxies meet, their stars mostly pass like ghosts, but their gas clouds crash and ignite bursts of star formation, new lights born from the turbulence. In the far future, our Milky Way will kiss Andromeda in such a dance, a slow merging that will change the map of the night, but will not necessarily be an apocalypse for individual systems. Time grants the universe a kind of patience we cannot fully fathom. Let us touch, briefly, on endings and beginnings folded into one. Stars of certain masses end their lives with a final flourish. They swell into red giants and drop outer shells that smell of future gardens, planetary nebulae, whose glowing rings are nothing less than stellar farewell notes. Some massive stars go out as supernovae. They explode with a brightness that can outshine entire galaxies for a while, scattering heavy elements into the void. These explosions are fertile. They pepper the interstellar medium with the seeds for future planets and life. The iron in your blood was once inside a star that died in fire, and then there are rarer endpoints. Neutron stars compacted into the mass of the sun, but squeezed into a city-sized sphere. Spinning so fast, they sweep beams of radiation across space like distant lighthouses. When 2 neutron stars merge, they ring the cosmos in gravitational waves, ripples in space-time itself. These ripples are like the faint tremors of a gigantic bell, small on our scales but monumental on a cosmic ledger. We have learned to hear them, to listen to space-time, and in doing so, we have opened a new sense. Now imagine, for a slow moment, a distant sea, where bioluminescent organisms light up like stars in miniature. Each little flash a private signal, an invitation, a memory. On some exoplanets, life, if present, might glow under active skies, or it could be hidden within subsurface oceans under a frozen crust. Moons like Europa or Enceladus, in our own system, hide oceans beneath icy shells. There is something deeply consoling about water kept warm and dark for aeons, about the patient possibility contained in enclosed seas. If life exists elsewhere, perhaps it is quiet, tucked into corners where chemistry can be steady and undisturbed. Let your thoughts wander to civilizations which may exist as brief candle flares along a long timeline. The technological curve of a species could rise quickly and fade due to self-made or natural disasters. It could also plateau into a sustainable, quiet stewardship. We do not know. We only know our own species' late curiosity and the sudden brightness of our signals leaking into space like dandelion seeds in a wind. Radio and light-based signals expand outward, thin and faint, like footprints in powder snow, detectable at a distance if someone is both listening and clever enough. There is comfort here too. Loneliness on cosmic scales does not mean emptiness. The cosmos is full of patient processes. Life and intelligence, if rare, may be spread like scattered campfires across an enormous plain. And perhaps the act of knowing, of looking, measuring, imagining, binds us into a community with the rest of the cosmos. In studying stars and particles, in parsing spectra, and building telescopes, we cast ourselves as students in a grand school. As you listen, either with your ears or with your mind, feel the rhythm of the universe as a lullaby of durations. A human lifetime is a handful of breaths compared to geological ages, and geological ages are a blink beside cosmic epochs. Yet within a single heartbeat, we can hold awe, grief, curiosity, and love. These human scales are not failures of perspective. They are the universe experiencing itself in a compact, fervent form. Now, imagine returning home, descending slowly from the bright cathedral of the galaxy, through the still, cold arms of interstellar space, past the commuter belts of comets, past the warm glow of a friendly star. You approach a tiny blue planet, the home you know. From orbit, continents are soft petals and storms curl like calligraphy. Cities are small nodes of light, patterns of habit and story woven together. On one such night, someone looks up with an ancient sort of yearning, recognizing in the dots above both estrangement and kinship. To end, consider this quiet, generous truth. You are made from the same elements as the stars, and those elements have traveled cosmic distances to arrive, patient as rain, into your bones. Your thoughts are shaped by molecules forged in fire. Your curiosity is a continuation, an echo of the processes that stoke stars and fold galaxies. In that sense, the cosmos is not merely something outside, it is an inheritance and a companion. So let tonight be ordinary and extraordinary at once. Let the soft knowledge of distant light settle in like warm dust. If sleep comes, let it be gentle, like the slow drift of an orbit. If your mind wanders, let it wander along the spiral arms, where new stars are still being hatched. Tomorrow, when you open your eyes, the world will feel familiar and newly strange, and you will carry with you the hush of long distances, the patient grammar of the universe, and finally, a closing image. A small child on the threshold of a house, holding a lantern. The child is not yet sure what stories will come, but they are learning to read the sky. The lantern casts a gentle circle of light, and, within it, the child's face is full of person-sized astonishment. Outside that circle unfolds a darkness so wide and generous that it invites stories rather than denies them. Walk now into that small, safe pool of light. Breathe, and let the vastness sing you slowly into rest. Good night. Hey there, wherever you're watching from, and whatever hour it happens to be, welcome to Bedtime Universe. Leave your city and the time down in the comments so the stars know where to send their postcards. Now settle in, breathe slow, and let me guide you into a story that unfolded on the quiet edge of our understanding. A story about an interstellar visitor and the small, human moments that met it. They called it 3i, Atlas at first, a tidy tag, for a thing that refused to be tidy. It arrived, like a rumor, across the gullies and radio dishes of our instruments, a pale whisper against the velvet background of the sky. For days, the feeds filled with numbers, angles, velocities, flux measurements, and an odd, spreading hush that happens when the universe hands humanity a riddle. If you imagine the object as a traveler, then the first thing to know is that it did not rush. Where meteors and comets streaked in quick-handed dramas, 3I Atlas drifted as if reading the pages of the sun's light. It slid into the solar system on an eccentric, unhurried path, its motion traced and retraced by computer models on benches in observatories around the globe. People who study the heavens are a practical lot. They make hypotheses and they puncture them. That is how progress is made, and so hypotheses came first. Pressure from solar photons? Sure. Sometimes thin objects slow as sunlight piles up on broad light sails. Outgassing like a comet? Perhaps. A fragment of something tumbling, caught by unseen tides? Possibly. The models said these were all plausible, but observation, patient as tides, said otherwise. It slowed, not once, not in the messy jitter of gas vents, but in gentle, rhythmic pulses. Each pulse matched a heartbeat of its spin. The spectrographs, the instruments that unspooled light into color as one unravels thread, told a second, stranger story. A density less than a tenth of water. Not solid rock, not a dense nucleus. Hollow, perhaps. A shell, a thing with more inside than out. The James Webb Telescope peered at it, and, for a time, all the night sky maps seemed smaller by comparison. We are used to comets with fuzzy comas, gas and dust billowing like poor curtains. Around 3I, Atlas, there was a halo, but it was not ordinary. It glowed a greenhouse green when seen through certain filters, and that glow did not carry the chemical fingerprints we recognized. Some nights, the halo shimmered as if threaded with electric light. Other nights, it lay like a diffidence, a caution against the dark, and there was rhythm. Swift's instruments, quick to catch elusive flashes, reported a precise emission near 497 nanometers. A pure green flicker that pulsed every 22 minutes. Not random noise. Not cellular decay. A metronome. It repeated, patient as tidal breath. When news spreads, it curves the world. Street-side cafes filled with impromptu lectures. Old lovers, separated by years, shared the same headline and felt nearer for it. Schoolchildren made paper models and named them in bright markers. Scientists, the ones with their sleeves always a little peppered with celestial dust, moved like people carrying fragile truths, cautious, thrilled, exhausted. Then came the nights when observatory feeds went silent. Data streams aborted mid-sentence. Schedulers found gaps where there had been none. That is a human drama written in the language of missing zeros and halted timestamps. It made people whisper about control rooms, about intentional curriculums of secrecy. Conspiracy is the shadow cast by fear. It thrives when information contracts and hope inflates. But the instruments that could still see were stubborn. They watched 3I Atlas slow again, and in defiance of many neat equations, nudge its course toward a capture path between Mars and Jupiter. Around us, debate flamed. Capture by gravity or a deliberate change in vector? If a craft could aim, would it loiter in the belt where asteroids ring like dubious sentinels? Or was it choosing a sheltered nursery, a place to rest? There were nights when you could almost expect a word to appear on the dark, a phrase spelled out by the pulsing green. But the sky is not obliged to speak in English. If it speaks at all, it speaks in wavelengths and probabilities, in the elegant coldness of math. So the story turned to the more human elements. The small, stubborn attempts at contact. Messages went up from modest radio arrays in countries that rarely make headlines, sequences of prime numbers, a child's simple song in Morse, a poem recorded at the end of someone's shift. If you think of communication as a bridge, it was as if people everywhere laid down planks, sometimes song, sometimes static, and waited to see if the bridge would be crossed. For a while, nothing came back. Then, in a way that was both subtle and undeniable, instrumentation registered a change in the pulse. The green blink that had been a metronome loosened and stretched, like a hand easing open a fist. There was modulation now, a pattern that mapped not to noise but to structure, a phase within a phase. It invited speculation that was, for once, both scientific and tender. Perhaps the object was trying to understand us, the way a traveler, tasting local words, learns the kindness in a hello. The idea that anything could be engineered by sentience is a heady thing. When the hypothesis surfaces, it draws both the best and worst in us. The wonder of a possible other, and the fearful borrowing of storylines from old science fiction. Many scientists insisted on caution. Extraordinary claims require extraordinary evidence, they said. And they were right. But we are also creatures of curiosity, and curiosity walks like a child down a long, dim hallway until there is an open door. In that hallway lived Aria Thorne, an orbital dynamics specialist who taught with hands that always seemed to be explaining something the fingers had just discovered. Aria did not believe in wonders as a religious act. She believed in them as a procedure. Check the numbers, rerun the model, test the instrument. She lived between equations and nights. Her apartment was a small observatory of mugs and data printouts, a map dotted with coffee stains where she had once spilled caffeinated impatience. Aria had, for years, been studying small bodies that danced too neatly to be chaotic. She loved patterns the way some people loved music. So when the 3i ATLAS pulse matched a rotational period and then modulated in ways that hinted at purpose, she stopped sleeping properly. She leaned into the data and let nights unwind into code and graphs. The first time she walked to the window and saw the object through the blind light of the city, she felt the strange sensation of meeting an animal that knows your name. It was not that the object glowed like a city beacon. It was that the world around her seemed quieter, as if the universe had shifted to make room for a conversation. Her colleagues sent messages that were halfway between professional rigor and personal bewilderment. The scientific community is a common language, but in those days it was also a living thing, the way a village shares news by hearth. Labs coordinated. Amateur astronomers in remote provinces picked up the thread. Their little telescopes, like lighthouses for the curious. Someone in a small island nation discovered a frequency offset that tied to the 22-minute pulse. Someone else found micro-variations in light that matched plausible structural reflections. The pattern of discovery was not clean or linear. It was messy and generous, a collaborative art. When the object's path bent toward a more stable orbit, the world held its breath. Imagine, for a moment, a cosmic stranger deciding to lodge itself in our backyard. Planets are practical things. They hold onto objects with gravity's patient fingers, and capture means presence. For some, the capture meant danger of foreign artifact near our homes. For others, it meant company, a chance to study without hurry. Aria argued for restraint and curiosity in equal measure. If 3i ATLAS carried intelligence, she reasoned, we must be careful not to frighten it. If it did not, we must still treat it as an unprecedented chance to learn. On a moonlit night, she sent a test. not a shout, but a handshake, a radio sequence of simple mathematical constants, followed by a recording of rain on tin, the sound of home in a universal rhythm. She thought of signals as translations of intent. Answer came not as words, but as nuance. The green blink shifted to match a component of Aria's signal, not copying, but echoing. The echo was garbled, but unmistakable, like the alteration of a song when a new choir learns it. Scientists called it reciprocity. For those who had pumped waves into the dark, it felt like a nod. Rumors blossomed in parallel to the science. Some claimed that agencies around the world were hiding whole chunks of data. Others swore they had seen ships, military vessels, repositioning beneath the quiet sky. People who live by rumor are not always malicious. Sometimes they are simply human, trying to stitch meaning into uncertainty. The truth, like much truth, lodged in a place between extremes. Not all data was withheld, but not all data was shared promptly. Bureaucracy and caution are mortal foils to enthusiasm. It was a woman in the Azores, a retired schoolteacher with a battered camera and a habit of photographing ships at dusk, who caught something everyone else had missed. She sent the picture to a mailing list of enthusiasts and, in the margin of her email, added, "I can't prove it, but the light was like the inside of a watch." The photograph showed a faint, comet-like object with an odd shadowing that suggested internal cavities. The internet, as it is wont to do, turned that whisper into chorus. Filmmakers started planning documentaries before the scientific press released full papers. Lovers wrote poems and posted them in small, tender fonts on pages where astronomy and yearning met. The object's green halo continued to puzzle. Spectroscopy suggested the emission might not be chemical at all, but plasma-like, an ionized environment dancing in magnetic loops. Magnetism is the secret path of many cosmic interactions. It can steer dust, it can sculpt the shape of a glow, and most importantly, it can be shaped by the intention of a structure designed to manipulate fields rather than shove matter. Engineers argued that creating a large, light, hollow structure that could exploit stellar radiation or magnetic fields to maneuver was within the bounds of sophisticated technology. The idea was not cheap science fiction. It was engineering stretched to the ambitious edge. The more Aria thought about it, the more she saw the design logic, a shell that trades mass for maneuverability, a surface that learns to whisper to charged particles. If natural processes can mimic some of that behavior, she admitted, the match would still be improbable. Over cups of too strong coffee, committees assembled to plan a measured response. There were proposals for probes, for gentle flybys that would learn composition and structure. Some proposed a more audacious approach. Send an emissary payload that would orbit the object like a small, civil-mannered friend. The plans were expensive, and expense breeds delay, so the world waited and watched. And then, one evening, the object did something that no simulation had predicted. It adjusted its pulse in a way that favored a particular band of radio frequencies, as if nudging an ear toward the human chatter below. The effect was small but symbolic. For the first time, our collective noise and its green pulse entered an alignment, a patterned duet. For Aria and many others, the moment was less an answer than an invitation. We are wired to anthropomorphize. We love the idea of intent because it gives us the pleasure of recognition. But alongside that human yearning, many voices reminded everyone of the scales involved. Any entity that could travel between stars had a patience whose length mocked human schedules. Our hurry is a short instrument. This thing could afford to wait. It may have no interest in the petty concerns of our politics or our fear. It might have been passing, a mariner looking for a pause in a long voyage. Yet we could not help ourselves. The public began to dream in broad, earnest ways. Artists painted the halo in colors physics could not name. Children insisted that the object be given a friendlier name than 3I Atlas, and so drew stars into letters and called it green light. Newspapers printed speculative editorials alongside op-eds about the need for global cooperation. For a while, the word cosmos took on a softer weight. It was not only distant physics, but a place where something might sit and read our postcards. When the first amateur radio operator, a man who lived with more wires than furniture and had fingers stained by old solder, recorded a reply that mapped to one of his own simple sequences, the logs filled with messages of jubilation, it was not so much that any single person had gained a declarative answer. It was that the sky had admitted the possibility of two-way attention. The world, for a thin slice of nights, felt smaller in the most consoling sense. But with intimacy comes the question of motive, and with motive comes unease. If the object was engineered, who sent it? Where did they come from? Were they explorers, observers, surveyors, or something else? The public conversation shifted, not toward panic, but toward a sober wonder. Philosophers were invited on broadcasts, and poets read in the glow of telescopes. Small rituals emerged in cities. Neighborhoods turned out lanterns one evening and hummed recorded rain, as if inviting a guest into a courtyard. Aria often thought about the object not as an enemy nor a savior, but as an argument. It forced humanity to choose how to behave when faced with the unknown. Would we respond with generosity and curiosity? With territorialism and fear? She wrote papers with painstaking caveats and also tried to write letters to the general public in plain language, urging patience and a thoughtful stance. Science is a method, she wrote, but it is also a habit of kindness toward truth. Careful listening, slow response, an acknowledgement that our models are maps and not the terrain itself. Months slipped like soft coins into a fountain. The object settled into a lopsided orbit, a new permanent sort of visitor sitting between Mars and Jupiter like an unspectacular gate. It did not present open doors or harsh demands. Instead, it continued its steady pulse, sometimes brisker, sometimes more languid. It rotated with the uncanny steadiness of a clockwork animal. In the quiet times, and there were quiet times, long afternoons when nothing seemed to happen, people learned to look at the night again as a shared apparatus of attention. Amateur skywatching groups cropped up in suburbs and urban rooftops. Children learned to identify constellations and the names of telescopes, as if learning the titles of new friends. The flood of conspiracy news slowly ebbed, replaced by slow non-fiction papers that walked readers through methodology and measurement with a human voice. One winter, when the nights were clear and the world smelled of wet pavement, Aria found herself sitting in a small room in the observatory, her hands wrapped around a mug gone cold. She had a folder of printed telemetry and a single line written in a margin by an undergraduate intern in a messy, hopeful script. If they are listening, we should tell them what we love. The thought lodged itself in her like a small compass needle, so she arranged a transmission, not an offer, but an offering. A patchwork of small human things, a set of prime numbers, the notation of a lullaby, the frequencies of whale song, the rhythm of a heartbeat recorded from a newborn in a distant hospital. With permission, the smell of rain approximated in waveform, things meant not to coerce, but to reveal. The message was small and human and oddly brave. It was the equivalent of setting a place at a dinner table and hoping the guest would not mind. For a time, nothing came. And then, in the same way the earth moves, and the tide answers the moon after an interval we cannot perceive until the water is already out. The object modified its green pulse and, in a pattern that was not direct copying but a gentle reshaping, repeated a motif from the lullaby. It was not a translation, it was a reflection. If an answer is a mirror, this was the kind of mirror that yields back what you look like when you are being kind. There are things in the world that change us, not by cataclysm, but by example. The presence of 3I, Atlas, became one of those things. A slow education in how to be patient, how to treat the unknown with a measure of courtesy we had not practiced enough. We made new committees and revised old protocols. We drafted treaties that opened pathways for shared calm. And at the most human level, people sat on rooftops and pointed at the green glow and imagined what the journey must have been like for something to cross the gulf between stars. Years later, when the object had become less headline and more fixture, a child in a small city who had grown up watching the pulses and who had learned to hum the lullaby as one of the minor domestic songs, stood in an observatory with her science fair project and wondered how to say thank you to something that had altered a culture without a single manifesto. She sent a drawing into space on a quiet daytime radio beam, a circle with a dot in the middle, encircled by dots of many colors, an invitation to sit, to look, to be curious. Whether anyone on the object side ever received the drawing is a question that sits patiently in a drawer, marked, might be answered later. It was also the simplest science, taking data and making meaning, converting space between hearts with signals that are at once arbitrary and essential. If you look up now, tonight, from wherever your eyes tilt to the dark, you might catch the faint memory of its green halo, or you might see ordinary stars only. Either is a kind of miracle. The story did not resolve into answers that fit neatly into a textbook. It remained, instead, an invitation to the long practice of learning. It taught us how to wait without paranoia, how to respond without arrogance, how to treat a visitor like a neighbor until it proved otherwise. So when the night deepens and the lamp beside your bed warms the page of whatever you hold, think of this small, steady object that slowed in our sky and pulsed with a rhythm we could recognize. Think of the scientists who stayed up late and the amateur astronomer with the battered camera. Think of that fallen cup of coffee and a note in a margin about what we love. Think, too, of how a world divided by so many small grievances can, for a moment, look up together and be humbled by the strange courtesy of the cosmos. Good night, from Bedtime Universe. If you feel moved, tell us in the comments where you are and what time it is. Let the green light of your place shine in our map, and sleep, knowing the sky is a little fuller, a little kinder, and that we are learning the long, patient language of listening. Hello, Bedtime Universe family, wherever you are watching from and whatever time it is for you. Tuck in, make a soft cup of something warm if you want, and drop where you are and the local time in the comments below. Tonight we drift together toward a small, bright visitor from beyond our system. A visitor that learned to change in ways the books did not fully expect. This is the story of 3I Atlas, and the night the sky rearranged itself around a secret. They called it a comet when it first came into view, a faint, humming speck that cut across telescopes and notices with the indifferent authority of a thing that must simply be catalogued. It arrived on trajectories and coordinate tables and polite conference calls. It passed through the columns of physics textbooks more like an elegant footnote than a revolution. It was, at first, an object that fit the vocabulary of our science, a hyperbolic wanderer, traveling from the dark between stars bearing ice and dust, and the slow mechanical inevitability of gravity. There is a calm arrogance to that expectation, as if the universe were a library and every new item would submit quietly to a shelf. But the night after perihelion, the library shifted a little on its axis, and a book opened to a page that no one had quite seen before. Perihelion came and went, like a breath drawn near a warm light. The comet plunged closest to our star, then slipped into the sunward glare that hides more than it shows. For several days, Earth-bound eyes could not hold it. Instruments that watched the sky from our planet left gaps where the comet might have been. Calendar boxes marked with an absence. In that absence, the comet did something private. On the 5th of November, the first cautious observations after the hidden interval hinted that it had not returned unchanged. The light that left it carried a new cadence. Where previously a single soft fan of dust and a faint linear tail of ions might have been enough to describe it, now there were irregularities, patterns of brightness that suggested a life of their own. They were tentative notes played behind a curtain, barely audible and therefore irresistible. Then on the 10th, a clear photograph arrived from the Virtual Telescope project, a frame of the comet that would reroute a dozen conversations. The image showed a tail that was not one tail but a chorus of ribbons twisting in the solar wind. Several bright filaments traced curves like the faint outlines of calligraphy, and between them lay a fragile lattice of fainter strands. The ion tail had become structured, as if the comet had found a way to write with the invisible hand of the solar wind. To look at that picture and still insist on simplicity would be to have missed the point. The tail no longer lay flat against expectation. It curved and folded and contained variations in brightness and density that argued for a three-dimensional choreography far beyond simple emission. The ribbons suggested pulsed releases of gas, a sudden change in outgassing, or perhaps an interaction with an unseen velocity shear in the solar wind. The discovery forced a question. What had changed while the comet was hidden in the sun's glare? Comets are artists of perspective. Their dust tail trails in a gentle arc determined by the interplay of inertia and radiation pressure. Their ion tail, by contrast, is a compass, always pointing away from the sun, blown out by charged particles and magnetic fields. So when an ion tail appears unexpectedly structured, what we are seeing may be a map of forces rather than of the comet itself. Yet, the thing that arrived on our images suggested agency that refused to be explained away by vantage alone. Scientists began to reconstruct the geometry of the encounter, folding time and position into three-dimensional thought. A small change of angle between comet sun and Earth can mean the difference between a tail pointing edge-on and an almost side-on display. For days, the comet might have kept its iron plume pointing directly away from Earth, hiding behind the bright coma and nucleus like a secret held against the sun. A slight pivot as it moved outward could suddenly reveal the full complexity of the tail, like a dancer turning to show a previously hidden flourish. That is part of the truth. But it is not the whole story. The brightness did not simply change. The rate of change and the pattern of motion contained whispers of non-gravitational acceleration. That is to say, forces other than gravity nudged the comet in ways that obeyed no simple formula. Spectra returned with lines that made spectroscopists sit up, lines that suggested ions in unusual abundances and molecules arranged in ratios that did not match a typical local comet. There were hints of heavier elements and of electrons switching dance partners in ways that promised stories about the material itself, about the origin of those ices. Some in the observatories spoke carefully of fragmentation of a payload, of deeper layers exposed by a near miss with intense solar heating. Others offered more speculative accounts of internal structure. A stratified nucleus containing layers of volatile compounds that sublimate at different thresholds, like wood, resin, and frost, giving the comet an episodic breath as it warmed. The ion ribbons might be the signatures of jets turning on and off like the breath of a living being. Those rational models fit some data, but not all. In the margins, where the more poetic and more patient scientists kept their notes, there were phrases like complex electromagnetic interactions and solar wind shears. The Sun is not a simple blower of particles. It is a braided field of magnetism, a storm track in plasma. A comet that carries an unusual magnetic signature or that contains charged grains may be sculpted by those invisible currents into filaments and arcs. If 3I ATLAS was carrying dust that held charge differently, or if its coma preferentially ionized in sudden pulses, the solar wind could weave that material into the ribbons we saw. But part of the late-night conversations also confronted origin. This comet is not native to our system. It is an interstellar messenger. With that ancestry comes the possibility that its material is unfamiliar in proportion rather than degree. The molecules locked in its ices might preserve chemistry from a different star, a different chemical climate, where formation recipes yield odd stoichiometries and strange grain structures. If so, then the comet is not only a visitor but a sample returned by fortune to our laboratories. It carries with it the memory of another disk of gas, another primordial chemistry. The image of the iron ribbons became a kind of Rorschach test for curiosity. Some saw the result of geometry and electromagnetism only. Others saw evidence of layered internal structure revealed by extreme heating. A few suggested that the comet had shed a thin outer shell near perihelion, exposing an inner architecture that outgassed in narrow jets, creating the striped tail. Yet those models struggled to reproduce the observed acceleration and unusual spectral lines, unless one allowed for exotic concentrations of volatile species, or for charged dust of unusual size distribution. Night after night, the observatories sent data, and the data pushed back, asking for more imagination. Radio telescopes listened for thermal emission and found slight deviations in expected flux. Space-based assets that could look closer to the Sun provided glimpses of the comet while it was hidden from Earth's ground-based gaze, but their view was still limited by instrument sensitivity. The situation underscored the crucial truth that perspective can turn absence into presence. The same event can be invisible or astonishing, depending on the angle and the instrument. There is a gentle cruelty to astronomy. We are often forced to reason from shadows to substance, to build a model of a thing that has rotated away from us. For the comet, this meant that a full explanation would be built from geometry and timing, and small changes recorded with great care. The sequence of outgassing pulses, the measured whips of acceleration, the spectral fingerprints of ions, all had to be fit into a coherent tale. The tale that began to emerge was neither tidy nor sudden. It was a tapestry of processes, sometimes cooperating, sometimes competing. The perihelion had heated the nucleus unevenly, exposing pockets of volatile material beneath surface layers that had been baked hard over eons in interstellar cold. Those pockets, when exposed, behaved like bottled storms. They vented gas in short, intense episodes, releasing ionizable molecules in belts across the surface. The solar wind then caught those released plumes and braided them into filaments, shaped by local magnetic field directions and by transient reversals in wind velocity. Tiny charged dust grains, embedded in the flow, increased the contrast of the filaments by preferentially scattering sunlight. But still there were unresolved details. Why had spectral lines suggested surprisingly high proportions of certain lighter molecules and anomalies in ion ratios? Why had the acceleration included components that seemed to come and go in ways correlated with tail structure? The answer likely lay in microphysical detail. The grain size distribution, the manner in which dust grains charged the pattern of surface porosity. Those are measurements hard to obtain from afar. The story of 3I ATLAS is as much about our relationship to the sky as it is about the comet itself. The discovery of the structured ion tail reminded us that our models are models, not scripture. They are the best languages we have to describe the universe, but not the only possible languages. We also discover the limitations of our viewpoint. For weeks, the comet became a teacher. Graduate students rose at odd hours to watch the data drip in. Amateur astronomers with telescopes on rooftops sent their snapshots and voices into mailing lists. Crowds gathered behind online feeds to whisper astonishment. People who had never thought about ionized plasma learned to imagine magnetic field lines as ropes in a cosmic wind. Children asked simple questions whose honesty forced crisp answers. There was also an ethical undercurrent in the discourse. The event showed why investment in spaceborne observatories matters. When a comet hides in the sun's blind glare, the only way to maintain continuous observation is to leave Earth behind. A constellation of instruments with different vantage points becomes more than convenience. It becomes capacity to see without the distortions of a single geometry. The revelation of 3i ATLAS was a small argument for more eyes in space, not because space is romantic, but because nature hides its tricks well and tends to reveal them only to the patient and the prepared. At night, I imagined the comet itself drifting outward, now past the point of closest stellar embrace, carrying the memory of heat, the scars of sublimation, the tiny scars where jets punched new vents. In its wake, the solar wind would continue to pull the ionized material into ephemeral sculptures that would dissolve and reform as conditions changed. Down on Earth, we would watch and speculate and collect, and perhaps in time, send probes to intercept smaller, interstellar visitors and to taste directly rather than infer. There was also a quieter lesson, the human one. In the face of unexpected complexity, the community did not splinter. Scientists argued and disagreed and published and revised like clockwork, but the argument itself was a gesture of curiosity rather than of terminal certitude. News segments would sometimes escalate the language to alarm, but the nights in data rooms were full of patient work and gentle wonder. For those who had chosen astronomy because the sky speaks to the imagination, this comet was a poem written in light and charged particles. And so the comet continued to recede toward the dark between stars. Its revelations would persist only in the data recorded in archives, images, and spectra, and in the subtle way that models bent and stitched to accommodate it. Future comets would be compared to it and would be read against the new vocabulary it had forced into use. Perhaps in years to come, someone writing a textbook would place a footnote in a chapter on comets mentioning the night when an iron tail unrolled its ribbons and taught us to look again at what we thought we knew. In the end, perhaps our most honest description of that night is simple. When the angle changed, we were ready enough to be amazed, to learn, to measure, and to imagine. And in doing so, we widened the small circle of things humanity knows how to name. So close your eyes and imagine the comet as it drifts quiet and bright across emptiness. Imagine the sun's breath shaping delicate ribbons that shimmer and then fade. Imagine the patient work of people on Earth who translate those ribbons into sentences of explanation. Imagine our hunger to know, not as a hunger to own, but as a desire to listen. If you like this story and want more, I can continue the tale, extending into a serialized sequence, exploring the comet's microphysics, a fictional mission to sample it, and the philosophical weight it carries for people who learn that. Visitors from other stars are more complex than we imagined. Tonight, we leave the comet on its slow, outward arc, and with the knowledge that the sky still keeps surprises, and that surprises are a kind of kindness to curiosity. Good night. Stay curious and gentle with the dark. Hello, dreamers. Welcome back to Bedtime Universe. Lay your head down, breathe slowly, and let the room around you dissolve into a soft, velvety hush. Tonight I will tell you not one quiet tale, but many threads of human curiosity and cosmic mystery braided together like a slow, luminous rope that pulls us out beyond our familiar shore. These are stories that have traveled, in some form, from watchful telescopes and busy laboratories, from deserts where astronauts learn to listen to the wind, From the clever hands of students sketching life support systems on napkins, and from the deep, patient light of newborn worlds, each thread is a small miracle. Each breath you take now travels the same physics that carries starlight. Let us begin. Imagine a field of dust that is almost too fine to notice, a gossamer of grains smaller than a fingernail, circling a young star. For eons, the dust whirls in slow, patient currents, colliding, sticking, growing. Sometimes those grains gather into pebbles, then into rocks, then into something with gravity, with a faint warmth, with a tiny, greedy appetite for more. In the glow of distant instruments, we have not just imagined, but watched this process in motion. Recently, the human eye in space, the James Webb Space Telescope, trained its golden gaze on a massive planet, encircled by a disk of dust and gas, and found evidence that within that ring, the raw chemistry to build moons is present. It is the very stuff of small worlds, hydrocarbons and carbon dioxide, the whisper of molecules that, over cosmic time, might clump and spin into moons of ice and rock. We are watching, in a way that would have seemed magical to earlier generations, a construction site for moons around a faraway planet named CT-CHA-b, some 625 light-years from our own sea of blue and green. Now let that image fold into another. Picture a planet so recently formed that it still glows with the heat of its own birth. Imagine light wrapped around it like a shawl, a fragile violet halo in the cold, dark. Astronomers have been lucky enough to capture direct images of such newborn worlds. These are not the distant, cold rocks that circle in silence around our own Sunday. These are infant giants, flecked with warm light, waltzing within the very rings that made them. One of these discoveries was announced with the wonder of a discovery alert. A baby planet photographed in a ring around a star. A minute, hopeful glow that tells us the universe is still busy making itself. The tidings came from careful telescopes and patient analysis, and they remind us that creation is not only in the past. Creation keeps happening, now, elsewhere, as you listen to this story. From the quiet work of the universe, we return our gaze, gently, to the busy, tender work we do for ourselves. In Houston at Johnson Space Center, there are new faces now learning how to be guardians of our ventures beyond the air. A new class of astronaut candidates has been welcomed, 10 in number, each chosen for a life devoted to training, to study, to listening. They learn to move without gravity, to care for each other in small, crucial ways, to swim through simulators that mimic a world with no flaw. They learn wilderness survival, so that, if the unexpected comes, they may adapt with calm and skill. Think of them standing at dusk, tied to suits that smell faintly of rubber and new fabric, watching the same moon you watch from your window. They carry not only their own hopes, but 1,000 small ambitions of engineers who made their rockets lighter, of teachers who once read them stories about the stars, of communities that believe in possibility, and yet, selection alone does not put humans back on the moon. There is a kind of gentle insistence in laboratories and university classrooms everywhere. Teams of learners and dreamers, building things that could one day become lifeways on other worlds. NASA's Human Lander Challenge stands like an open door. It invites students and innovators to propose life support systems, to imagine how a group of people might live and breathe and sleep in a place that has no atmosphere to hold them. The call is practical, and it is poetic. It says, "Help us build homes of air and warmth for people who have not yet set foot on the lunar dust." It asks for pipes and filters, for ways to manage heat and the cold, to scrub carbon and carry water where there was none. It is a challenge and an invitation to stitch human ingenuity into the cloth of exploration. The design sketches and late-night cups of coffee that form in response are as much a part of human exploration as rockets and telescopes. Now, allow the story to drift a little further outward until the dark is not empty, but full of steady points of light, each a story. The James Webb Space Telescope has been mapping more than single planets and disks. It has turned its instruments toward great nurseries of stars, places where clouds of gas and dust coalesce under gravity's patient pull to ignite the first clear flame of a new star. In a region called Pismis 24, Webb has taken a sparkling image of star birth, a tapestry of orange and near-infrared light that shows clumps of matter arranging themselves into tomorrow's suns. Each such image is an atlas of origin, a quiet ledger of the ways matter organizes and becomes luminous, a reminder that even violent births can be beautiful. The telescope's images are not just pretty pictures to hang in a gallery. They are evidence, data, that allow scientists to ask how galaxies are built, how thick stellar disks form, how environments shape evolution. In these portraits of birth, we can almost hear the slow exhale of the universe as new heat begins to beat. The human stories loop back and forth with these cosmic events. Students building lander prototypes imagine future astronauts walking across regolith stirred by engine plumes. Engineers who study particle physics design shielding to keep that astronaut's heart beating steady against invisible rain. Flights take to our own atmosphere to measure the air we breathe, with scientific instruments tucked into aircraft to sample tiny particles and trace gases. The same curiosity that has us peering at newborn planets also leads us to measure the breath around our cities and the flow of water after a fire. The data that orbiting satellites send down help protect the people on a hillside downstream from a burned watershed. Science is a conversation between distant glories and immediate care between the stars and the soil. Imagine a lab at night, the lights low, screens glowing like constellations. A team of scientists studies spectral lines, thin patterns of light that reveal the chemistry of a planet-forming disk. The patterns tell of hydrocarbons and simple organics, the building blocks of complexity. Elsewhere, a group of students assembles a prototype for transferring fluid without losing heat. A little farther on, an astronaut in training slides out of a simulator and rubs her hands together, thinking not of the instruments she will one day use, but of the person who will rely on her care in the small hours of an alien night. The tether that binds these moments is responsibility. Each discovery is met with the question, how do we make this knowledge useful? How do we keep people safe while they explore? Let us drift now past formalities and into a simpler human moment. Picture a child somewhere on Earth, wrapped in a blanket and gazing at a tiny LED projector on the ceiling that shows slow, twinkling stars. Perhaps she has heard of the Webb telescope's images. Perhaps she has read a small headline about a planet being photographed in a ring around a star. In that child's small mind, the universe becomes an immediate companion, a place of friends waiting to be met. That is the true power of what we do when we send telescopes into the dark. We give the next generation an expanded map of what is possible. You might imagine that space agencies and large telescopes are remote, their work cold and technical. But the truth is softer and stranger. It is a story of many hands, of late-night code that finally runs, of metal surfaces polished by apprentices, of teachers who press a paper telescope into the hands of a child. When Webb returned images of star formation, people anywhere with an internet connection could pull those images like a blanket over their lap and study them. The images cause wonder precisely because they connect the very small with the very large, the grain of dust to the gleam of a newborn Sunday. Think now about silence in space, where sound cannot travel the way it does on Earth. In the quiet between stars, telescopes listen in other ways. They read the fingerprints of light. They read shadows and cooling curves and the faint warmth of gas. The story of CT-CHA-b and its moon-forming disk was written in such fingerprints. It required patient observation and careful analysis, It is also a story that tells us something about the potential for complexity in other systems. It says that the processes that once formed our moon, or shaped our planet, are not unique. Elsewhere, in a dark ring around a young planet, dust and molecules dance out the recipe for new satellites, miniature stages where future geology and perhaps future chemistry will play out. Our world, meanwhile, keeps asking to be protected. NASA's instruments that roam the skies help scientists map how fires alter water supplies, how dust moves after an engine plume, how particles travel through our air. That knowledge helps a farmer know when to plant, helps a town understand the safety of its reservoirs, helps an emergency team decide where to put sandbags. The same curiosity that reads starlight becomes a tool of care on Earth. Now allow the narrative to fold in one more theme, the idea of apprenticeship and challenge. Challenges like the Human Lander Challenge are not only contests, they are classrooms with very public finals. They ask people to imagine the improbable and then make it real enough to test, to prototype, to fail, and to learn. Think of student teams whose hands are inked with schematics and whose whiteboards are full of scribbled equations. They are the ones who will iterate through failure to find something that works in the harsh vacuum and abrasive dust of the moon. Prizes and challenges push ideas forward, not by fiat, but by curiosity. As your breathing slows, imagine a single small scene that gathers all these threads into one gentle image. A young engineer sits before a screen displaying a glowing ring around a planet. On his desk is a plastic model of a lander. On the shelf, a faded photograph of the Grand Canyon. Beside him is a calendar with the dates of a student challenge he hopes to enter. Outside the window, a plane traces invisible ribbons in the sky as it samples the atmosphere. He thinks, quietly, of the future, of a person who will one day sleep under a thin dome on the moon, who will look up, not at clouds, but at a sky filled with Earth, and who will know that someone in a dusty lab once dreamed and sketched and kept going. He knows his work is small and essential. Stories like these are not all triumph. They are also full of patience and slow correction. Telescopes can mislead, and data can be ambiguous. Plans can be refined. What matters is the persistence of the people who care enough to examine the difficult parts and take the time to get them right. It is the same persistence that lets a child return to a puzzle until she understands it. It is the same quiet stubbornness that has led humans from carved stone to spacefaring craft. And now, for a last little voyage before sleep takes you. Imagine that the very dust that built those newborn planets someday seeded life elsewhere. Imagine also that our own small planet continues to require tending. The researchers who measure our air, the students writing code to manage life support, the dreamers drafting lander designs, the astronomers pointing Webb at a distant nursery. All are involved in a single, long labor of stewardship. The universe offers wonders without end. Our job is to learn how to reach them and how to live wisely beneath their glow. As your eyelids grow heavier, let the images settle like a soft film behind your eyes. See the golden honeycomb mirror of a great telescope, its facets catching faint infrared light. See the slow ring of dust around a distant planet, curled like a sleeping animal. See the new astronaut stepping out of a training pool, smiling at the absurdity and joy of it all. Hear, faintly, the hum of aeroplanes that check our air. Feel the gentle insistence of students and their challenges. Take one more long breath in now, and let it be full of stars and the cool chemistry of distant disks. Breathe out, releasing everything you have carried from the day. Lay your cares upon the pillow, and know for a quiet moment that human curiosity and careful tending continue all night and all day. People at observatories and centers of learning are awake in a different time zone, poring over small signals and long data sets. They will snooze and they will wake, and they will continue the work that expands what we can imagine. Sleep now, explorer. Dream of moons being born in the lullabies of dust and light. Dream of engineers whose sketches become habitats. Dream of young astronauts who will one day float by a window that looks down on a sleeping Earth. When your eyes open again, the world will have spun a little further in its orbit, and perhaps a new image will have arrived to remind us that the cosmos is never finished telling its stories. Good night, from all of us here at Bedtime Universe.